What we're going to look at now is finding sample size. Very simply put, before we do any kind of study, we want to have an estimate of how many people that we need to survey in order to get a certain amount of confidence with a certain margin of error. Now, if you look at our formula for a one sample t interval, you see that it's basically your estimate plus or minus t star sub n minus 1 times s over square root of n. This piece right after the plus or minus is your margin of error. So our margin of error formula simply becomes margin of error equals t star n minus 1 times s over square root of n. So now we're ready for an example. If the margin of error is equal to 8 minutes, and we think the standard deviation is 10 minutes, if I'd like to make a 95% confidence interval, what sample size should I use? Well, nicely enough, they gave us the margin of error, which we now know is 8. They also gave us what they think is the standard deviation, which is 10. We're solving for n. Our big dilemma really is that how the heck do I know t star with n minus 1 degrees of freedom if I don't know n? T depends on n. So this is all kind of like a little bit silly now because we're stuck. Unless we're willing to make some allowances. And in this case, since we can't figure out what t to use, we estimate t with our good old friend z. So simply put, instead of using t, we're going to use z, which in this case is 1.96. So 8 will equal 1.96 times 10 over square root of n. I'm not going to insult you by solving this out. You can solve your equation with the solve button on your calculator or cross multiply, but n ends up being 6.0025. Usually I say always round up sample size, but it's such a smidgen over that I've decided I'm just going to call it 6. So bottom of line, we use our margin of error formula, and because we don't know t, we substitute in z. Awesome. Next, we're going to look at computer printout. At North High School, the average number of cars owned by a family is 2.35. South High School is in a more affluent area of the town, and students claim they have on average more cars per family. An SRS of 36 students was selected, and they were asked how many cars are in each of their families. The number of cars is shown below. So basically what we're saying for our null and our alternative is that if it's status quo and South is the same as North, they'd have an average of 2.35 cars. But we think they have more, those lucky ducks. So our alternative is mu greater than 2.35. Of course, you want to define mu to be the average number of cars per family at South High School. Now, they were awesome here in that they gave you that the sample had a mean of 2.833 and a standard deviation of 1.056. Here's where I want you to look. This is a prime example of computer printout. Basically, they've done what you do on your calculator and just want you to analyze the output. So right over here, you could see the null and the alternative. Here is n. This is the sample mean. This is the standard error of the mean, which is just your s over square root of n. This is the t you would get if you went through doing it all out by hand, and here's your p-value. And obviously, with the p this low, we're going to reject the null. I know what you were thinking I was going to say, but I didn't say it. One more example of computer printout. This is actually from Laserland. I took the data from our first game and I looked at the number of shots and I said, well, maybe I want to show that on average the number of shots per game is more than 180, using that one game as a sample. And so what I have here is the sample mean for all 113 students. It tells me the degrees of freedom is 1/12 because it's n minus 1. It's done the sample standard deviation over square root of n. It's calculated out the t for me and given me a p-value. And obviously with the p-value this high, we would fail to reject the null. And we would not have evidence that the average number of shots per game is over 180. I've just shown you a little bit of information on calculating sample size and a little bit about computer printout. I'd like you to read page 546 to 549 and look at the computer printout on 553. Then try number 15 and 16. Good luck with your mission.